Okay, I'm going to talk a little bit about portable antennas. Right here, I've got a portable mobile antenna. It's a Hustler mast, 54 inches, and on top of the mast you put resonators, Hustler resonators, and I've got one for every band. In fact, I got two for some bands. I can take this antenna and I can put it on a tent stake, which is what I frequently do at different parks, and I can push it in the ground by hand with a tent stake. Now, I've been in a couple of locations where I get a really low SWR, like 1.5 or something, with no radials. Other places, or most places, I have to run out 2 or 3 radials. Occasionally 4 radials. So I made up a little kit of radials with power pole connectors on the end of them, and I've got pigtails on my tent stake mount. And I can push it in the ground. I can add a couple of radials real quick. Check the SWR, and if it's like 2 to 1 or 1.5 to 1, I can leave it as it is, or I can throw in another radial. And usually adding one more radial will bring it down to where the FT891 can't even tell it's got an SWR. It like reads 1 to 1, perfect. Now, we got 2 things going on here. Number one, we need to match the antenna to the coax so that the transceiver is happy, and that usually requires a 2 to 1 or better. And of course, obviously, the lower the better. The more bandwidth you'll have. If it's 2 to 1 in the CW band, you go up to the phone band, it's going to be 3 to 1 or more. If it's flat 1 to 1 in the CW band, most likely you can move up fairly high in frequency and still be able to operate. So that's one thing. The second thing is the radiation efficiency. And standing wave ratio of 1 to 1 and a radiation efficiency of 100% is not the same thing. So when we're working on portable antennas, we need to think, okay, we need to match the antenna, and then also, is it efficient? Typically, putting out radials is going to make it more efficient. If you have just a straight quarter wave whip antenna, you're gonna, when everything is all said and done, it's going to be like a 35 ohm impedance it presents to the 50 ohm coax, and that's not a 1 to 1 SWR. So if we have a 1 to 1 SWR, we know that quarter wave antenna is presenting a 50 ohm impedance to the coax. And we know that 35 of it or so is radiation resistance, while the rest of it is ground loss, or its losses. So we might want to put in more radials, and the SWR might come back up a little bit. You're gaining in efficiency, but you're losing in the SWR department. So, these things, that's just the way it is. So, with these mobile antennas, they're typically designed to match 50 ohms. So when I get down to a 50 ohm match with this antenna, I feel like I'm okay. And 4 radials is going to be okay. Typically, you're going to have to double the number of radials to see any difference, if you can see any difference at all. 3 dB is not something you're going to notice. Barely notice. 6 dB you'll probably notice. So when you put out the antenna and you add a couple of radials and you get the SWR down to where it's reasonable, and then you add a few more radials, that's probably as far as you want to go with a portable antenna. If you double the number of radials, you may get a dB improvement. you may or may not be able to detect it. It's probably not going to be worth the effort. You're not going to be heard any better with a 1 dB increase. So what we need to think about is how many radials do we really need? Well, that's confusing too. If you've got a certain length of wire and you run it out as just one long radial, that's not going to work as good as if you cut the wire in half and made 2 radials out of it. And that may not work as well as if you cut the wire into 4 pieces and made 4 radials. Now, as long as these 4 radials are going out fairly well spaced apart. If you got 4 radials going out just in the same direction and they're only about a foot apart, those 4 radials are not going to be the same as if you had those 4 radials spread 3 or 4 feet apart. So typically what we do is we run out in 4 directions if possible. If we can't go, like with the truck here, if it can't go in that direction, you can run 4 radials, 1, 2, 3, 4. Okay, that's fine. Now, if you want to increase the number of radials, you might want to space another radial in between those radials, and that'll be good. But if you add 4 radials just in that direction, those 4 radials are not going to have the, I'm going to say, the effective area, effective coverage that 4 radials would be spread out. Now, when you get to the point where you've got a fair number of radials, and we're talking short radials, I'm talking 10, 12 foot long radials here. So once you've got fairly good coverage with 10 or 12 radials, then the length of the radial starts to become more significant. So the more radials you have, the longer you want to make them. Because remember, you don't want those radials really, really close together. They need to be spread out. So right here at the antenna, they're going to all merge and come close together. And as they go out, they get further apart. So there's a point at which, and it depends on the frequency band you're using, it depends on the earth conductivity, there's a whole lot of factors here, but it gets to a point where these radials start spreading out, and now they're not real close together. Well, you run another radial, and out at that 11-foot point, they all start to get closer together. So maybe you go with 25-foot radials. All right, you get to a point where at the end of those 25-foot radials, well, there's a pretty fair distance. So you run some more radials in between those, but you make them all longer. So I guess the bottom line is the more radials you have, the longer they can be and be effective. And there comes a point when the radials are probably too long and they're not you just don't gain anything. Now I want to apply the law of diminishing returns. You put out a bunch of short radials, okay, you've gained quite a bit in the beginning. Then you put out a bunch of longer radials, and you gain a little bit more. Then you put out a bunch longer radials. Well, now you get to a point where the first set of radials, short radials, you significant improvement. You could hear the improvement. The next set of radials, which are longer, and when I say the next set, I mean increasing the length of the first set. So all the radials are no longer 11 foot. All the radials are now like 25 feet. And you've made a difference. I don't know if you can tell it. All right, and then maybe you go to all 50-foot radials. And you double the number of radials. And now you've got, well, you may or may not have gained much. It's like you gain 3 dB with the first set, you gain maybe 1 dB with the second set, And then when you put all the long radials on there, you gain a half a dB. You get to the point where you're not gaining anything anymore. You're just putting a wire on the ground. So there's no finite answer to how many and how long your radials should be. It's sort of a general thing. Yeah, you need a few radials. You need 3, 4, 5 radials would be good. And they don't have to be very long. They can be 10 or 11 feet. And then you double the number of radials. Well, you probably want to double the length of them. And then you want to double the radials again. Well, maybe you want to double the length of them again. And pretty soon, by the time you get out to a bunch of long radials, the law of diminishing returns has caught up with you. You are no longer gaining any improvement at all. Now, how do we know where that is? Well, it's different if you're on the marsh. If you're on the marsh, you don't probably need any radials at all. And the more radials you put out, you'll never notice the difference. If you're on very poor soil, like all sand or something, you may need quite a few radials. If you're in my backyard, once you get past about 4 or 5 radials, I don't think you can see any difference. Now, I'm still working on testing, but I'm doing a lot of testing with the reverse beacon network and working POTUS stations from my backyard, testing my portable antennas. And I'm frankly to a point where 4 11-foot radials is probably as far as I want to go right now. If I'm going to go activate a park, I'm probably going to take 4 or 5 10 or 11-foot radials. And I'm going to make a lot of contacts. I'm going to be happy. In my backyard, usually 4 radials I'm working DX with it. And I'm getting guys on the first call out in my backyard, unless it's a tremendous pileup. So, and I run about 50 watts when I'm playing around in the backyard with my portable antennas. And I run about 50 watts when I'm mobile with the Hustler here on the back of the pickup truck. So anyway, that's the I guess the first installment here of my talk about portable mobile antennas. And of course, we're concentrating right now on mobile antennas that are being used portable, or any kind of portable vertical antenna that needs radials. And we'll leave it with this. If you can put up a horizontal dipole, a quarter wave or a half wave in the air, you're probably going to beat any vertical you could ever put up, except for a vertical you put over a salt marsh. A vertical over a salt marsh is darn near equal to a pretty good high dipole. But if you're not on a salt marsh, a dipole at a quarter to a half wave is definitely going to beat the vertical. However, sometimes it's difficult to put up dipoles or in-fed half waves or whatever you want to use. I find a vertical mobile antenna on a tent stake gets me enough QSOs. I can work enough DX with it that if I'm portable, that's okay. Now, if I had the chance and I'm trying to work a D expedition and they had a big pileup or something, well, I might try to put up a dipole at a half wave. That would definitely be a better antenna. Okay, so that's it for today. This is N4DJ.